Describe the end behavior of the function 3x to the 17th plus 8x plus 5x to the 6th. So we have this polynomial, and the end behavior is referring to what happens as x gets very large or as x gets very small. We have the left end behavior. That means as x gets very small, that's going towards minus infinity. And then we have the right end behavior, that's as x gets very large, as x goes to infinity. And so the left end behavior is as x goes to negative infinity. The right end behavior is as x goes to infinity. Now, based on the degree of the polynomial, we'll be able to answer this question, and the coefficient that's on that term. So this polynomial has an x to the 17th, an x to the 1st, and an x to the 6th. The degree is the highest exponent on x, so this polynomial is degree 17. And so we have to note whether it's an odd or even degree. So 17 is odd, and odd degreed polynomials behave a certain way. As x goes to negative infinity and as x goes to positive infinity, they have opposite behavior. And so on the one hand, it could fall off and go towards negative infinity towards the left, but then you know for sure then on the right it's going to go towards infinity. Or the opposite would be true. It could rise on the left, do whatever in between, and then fall on the right. How do you decide which one this is going to be? Well, you decide which one it's going to be based on the coefficient of that leading term. The coefficient on that highest degree term. The highest degree term is x to the 17th. Its coefficient is a 3. Okay, and so that's a positive number. So when your coefficient is positive, you'll have the end behavior like what's above here. As x goes to negative infinity, the function is going to go to negative infinity. As x goes to infinity, the function is going to go to infinity. But had your coefficient been negative, meaning that I'm talking about the coefficient on that leading term, the highest degree term. Leading doesn't mean the first term, leading means the highest degree. The coefficient was negative, then it'd be reversed. As x goes to negative infinity, it's going to go to positive infinity, the function. And as x goes to infinity, the function is going to dive off and go to minus infinity. So we have this situation here, though. We have the situation where the coefficient is positive, it's odd. This combination together then tells you that as x goes to negative infinity, that's the left end behavior, the function is going to go to negative infinity. And as x goes to positive infinity, that's the right end behavior, the function is going to go to infinity. And whatever it does in between, we don't really care. We're worried about the end behavior. As x gets very large, you take a very large positive number and raise it to the 17th power, it's going to dominate these other terms, and it's going to be very large. But if you take a negative number and raise it to a very large, if you take a negative number and raise it to the 17th power, you'll get a negative number out. Negative 3 to the 5th power is a negative number. And so it's the combination of having a negative number raised to an odd power the result is negative. And that's what's going on with the left end behavior.